Hello, this is the last unit of our course, and in this unit we will be discussing graphing. Now the question is, what is graphing and what do we graph? Well, a graph is a pictorial representation of the relation between two variables. Now, a relation between two variables. What are variables? We have talked about it in detail about variables. Now, can you think of a relation between two variables? Think about you going to work. You work for a few hours and you earn some money. Is that right? Every hour you work, the money you earn increases. Now, the amount of time you work is a variable. The amount of money you earn also is a variable. Are these two variables related? Yes. If you earn $10 an hour, you work for $5, you get... No. If you work for 5 hours, you get $50. You work for 20 hours, you get $200. Is that right? Now, how do we represent the relation between these two variables? By drawing a picture. So a graph is a picture of the relation between two variables. Now, an equation containing two variables is a relation between those two variables. Okay, let's go back to our example. You go to work, earn $10 an hour. Okay? Let's call X as the amount of time you work and Y as the amount of money you take home. Alright, take your paper and pencil and write this down. X is the variable that represents the amount of time you work. Y is the variable that represents the amount of dollars you make. And for every hour you work, you earn $10. What is that relation connecting these two variables? Have you got that relation? Well, let me see if I can write that down for you. I can write it as, well, y equal to 10x. Is that right? Y equal to 10x. What it means is that when x equal to 1, you work for 1 hour, you take home $10. X equal to 2 hours, and I'm going to write it like this. Y of 2. What does that mean? The value of y when x equal to 2 is 10 multiplied by 2. That is $20. You see that? So, a relation between the two variables I can now write as y equal to 10x. Okay, I'm going to give you another example to illustrate another situation. For example, on a charity walk, you promise to walk 1 kilometer for every $2 you collect. I have a little girl in my neighborhood who comes to me almost every year, say, I'm going to walk for my charity. Would you pay me money for every kilometer I walk, $2 per kilometer? And I give her some money. Well, that's what I have used here. For every kilometer she walks, she collects $2. All right? Let's represent y as the amount of dollars and the variable x, the number of kilometers. All right. What will then be a relation between x and y in this case? Can you take your piece of paper and write that relation down? What is the relation between x and y? Well, did you get this relation? Y equal to 2x. For every kilometer she walks, she gets $2. For x kilometers she walks, she gets 2 times x dollars. Is that right? Okay, let's move on. Y equal to 2x is a relation between the two variables x and y. Okay, we will be using this as we go on. When x equal to 1, that means you walk 1 kilometer, then y equal to 2. Is that right? You collect $2. When x equal to 3, what will be the value of y when x equal to 3? If you walk 3 kilometers, then you collect $6. The value of y will be 6. And you can now give any value to x, and you can find the corresponding value of y. Is that right? Now, since you are free to decide the number of kilometers you want to walk, you are free to choose the value of the variable x. Is that right? You can say, well, I'm going to walk only 5 kilometers. That means that is your choice. Nobody else will force you to make that choice. And therefore, this x, where you are free to choose that value, we call that the independent variable. Now, why is it called the independent variable? Nobody will come and force you to choose a value of x. You can choose a value of x. So, x is called the independent variable. Then, could you tell me, what will then we call y? Now, remember, whatever value of x you choose, the value of y will depend on the value of x. And therefore, you can call the value of y as the dependent variable. Whenever you write a relation between two variables, there is always an independent variable and a dependent variable. Let's go back to the money you earn and the amount of time you work. Tell me, which of the two variables is the independent variable? The time you work or the amount of money you earn? Well, the time you work is the independent variable because you can decide how many hours you're going to work. Is that right? One day you fall sick and you can call your boss and say, I'm not coming to work today. Which means you are deciding on that value of x. Is that right? Okay, so you must understand the meaning of independent variable and dependent variable. Let's now talk about Cartesian coordinate system. A graph is a picture showing the value of the dependent variable. How does the value of the dependent variable change when the value of the independent variable change? You can now draw a picture showing how the dependent variable change when the independent variable change. You walk for 2 kilometers, you collect $4. You walk 3 kilometers, you collect $6. You walk 10 kilometers, you collect $20. You see, we can use that to draw a picture. Now, a graph is drawn on a system of coordinate axes, and you call that coordinate axis Cartesian coordinate system. Alright, let's see what the Cartesian coordinate system is made up of. I know most of you know this. Let's review it. The Cartesian coordinate system consists of a horizontal axis called the x-axis. There you got the x-axis. That is the horizontal axis. And a vertical axis called the y-axis. That's a vertical line, we call it the y-axis. So this is the most important part of a Cartesian system. A horizontal axis called the x-axis, a vertical axis called the y-axis. The point they meet is called the origin. That's the origin. And usually we give the value 0 for the origin. Let's go and have a look at that. So that is the origin, and the value of the origin will be 0. In other words, that is where you start, origin. Okay? On the x-axis, the number to the right of the origin. So if you if you have 0 there, what will be the number that comes to the right of the 0 on the x-axis? You will have 1, 2, 3, 4, 5 positive values to the right and negative values to the left. There you are. Look at this. On the x-axis, the positive values to your right, negative values of x to your left. Similarly, on the y-axis, positive values above the origin and negative values below the origin. And that is the characteristic of the Cartesian coordinate system. Okay, let's move on. Now, how about this? The x and y axis divides the whole Cartesian system into 4 quadrants. What is a quadrant? A quadrant is 1 out of 4. So you can see the y and x axis divides the Cartesian system into 4 quadrants. Alright. In quadrant 1, now this is quadrant 1. You notice that in quadrant 1, x values are positive, y values are also positive. Okay? There you are. Quadrant 1, x and y are both positive. In quadrant 2, look at this, this is quadrant 2. Tell me, what are the signs of the x and y values there? In quadrant 2, x is negative, y is positive. And that is quadrant 2. X is negative and y is positive. How about quadrant 3? This is quadrant 3. X is negative, y also is negative. There you are. In quadrant 3, x is negative and y also is negative. And how about quadrant 4? In quadrant 4, x is positive and y is negative. Is that right? X is positive and y is negative in quadrant 4. Well, we will be using these concepts as we move on. Let's now talk about the most important part of graphing. What is it? Ordered pairs. Ordered pairs. A pair consists of 2 values. Now, in this case, of course, we are drawing the picture of a relation between 2 variables. That means every time you look at the relation, there are 2 values. One for the independent variable, one for the dependent variable. Is that right? One value for x, and every time you assign a value for x, there will be a corresponding value for y. Is that right? Okay, let's look at the relation y equal to 2x. What does this represent? You remember? For every kilometer you walk, you collect $2. That means you can choose the value of x. You can choose how many kilometers you want to walk. And depending on that, you will get a value of y. Is that right? For every x value you choose, there will be a corresponding value for y. We can therefore say the values of x we can say as input values. Then the values of y will be called output values. That's reasonable, is that right? Okay. Each value of x gives a corresponding value of y. X can be called the input value, right? That one you choose. Then y will be called the output value. So for every input, there will be an output. Okay, let's use an input of x equal to 1. What will be the output? The output is y equal to 2. So, you can see there are 2 values in that particular situation. When you choose x equal to 1, the value of y equal to 2. Now, this is called an ordered pair. Now, it's called an ordered pair because it comes in a certain order. What is the value that comes first? Is it x or y? Tell me. Well, without an input, you cannot get an output. So the input always comes first, and then the output. And that's why it's called an ordered pair. A pair of values written in some order. The order is the independent variable first, and then the dependent variable. And look at the way we write an ordered pair. An ordered pair is always written inside a parenthesis. And it's written 1, 2. It means when x equal to 1, the value of y equal to 2. That's what this means. The ordered pair gives you an input and its corresponding output. That's right. Now, in an ordered pair, the value of x always comes first, followed by the value of y. The independent variable value is followed by the dependent variable value. Is that right? Okay, let's move on. We are going to continue our discussion using y equal to 2x. For the same relation, when x equal to 2, what does that mean, x equal to 2? You decide to walk 2 kilometers. What will be then the output y? Y equal to 4. Can you write the corresponding ordered pair? Alright, that ordered pair will be parenthesis 2, 4, parenthesis closed. That is the ordered pair for this situation. And you can now write any number of ordered pairs for that relation. And then we can draw a picture of all those relations, all those ordered pairs. Similarly, I said 3, 6 is another ordered pair. Do you agree with me? When x equal to 3, you walk 3 kilometers, you collect 2 times 3, $6. When x equal to 3, y equal to 6. Another ordered pair. Can you write down 5 ordered pairs of this relation on your own? Now do that on your own. You can hit pause on the video and do that on your own. Write 5 more ordered pairs on your own. Okay, I'm going to give you another one. If x equal to -4, well, that's something that you cannot actually do in practice. But now you're going to imagine. Here, this input value is an imaginary value. X equal to -4. If you put x equal to -4, what will be the output value y? Y will be -8. That means we can have an ordered pair. -4, -8 is an ordered pair there. Is that right? Okay. I'm going to give you a question now. Let's see how we can do this. Determine whether the following ordered pairs belong to the relation 2x plus 3y equal to 6. I've given you 2 ordered pairs, and you've got to decide whether these ordered pairs truly belong to this. Now, how do you test it? Well, all you need to do is take this ordered pair. This ordered pair says when x equal to 1, y will be also 1. So, what we need to do is replace this x by 1 and this y also by 1 and see if this relation is true. Now, how do you know if a relation is true? The left-hand side of the equation must be equal to the right-hand side. Tell me, is that true? Let's try it. Let's check it. How do we check it? Replace x by 1 and y also by 1 and see if the relation remains true. And I'm going to do that here. 2 times x is 2 times 1 plus 3 times 1 equal to 6. You see that? 2x plus 3y equal to 6. I replaced x by 1, I replaced y by 1, and the relation becomes this. Tell me, is this a true relation? Well, 2 times 1 is 2, and 3 times 1 is 3. 2 plus 3, as far as I know, 2 plus 3 is 5, not equal to 6. So you can see this is not a true relation. What does that tell you? It tells you that 1, 1 is not an ordered pair of that relation. What does that mean? It means when the input is 1, the output will not be 1. That's what it means. The output will be something else here. Okay, let's try this. 0, 2. When x equal to 0, the value of y is 2. Is that true for this? Alright, let's check that. How do we check it? Replace your x by 0 and your y by 2. Is this a true relation? What do you think? Well, I think it's a true relation because 2 plus 0 is 0 plus 3 times 2, well, 2 times 0 is 0 plus 3 times 2 is 6. 0 plus 6 is 6. Therefore, 0, 2 is an ordered pair of this. Alright, let's try this one now. Determine whether 1/2 5/2 is an ordered pair for the relation y equal to absolute value of x minus 3. Now, look at that relation there. That's a relation between x and y, an input variable and an output variable. The question is, when x equal to 1/2, will the value of y be 5/2? Again, how do we check it? Well, replace your x by 1/2, replace your y by 5/2, and see if the relation remains true. Alright, let's do that. In place of y, I write 5/2. In place of x, I write 1/2. And what remains for me to do is simplify inside the absolute value sign. Now, how many of you can do this? 1/2 minus 3. Now, to make it easy, this 3 can be written as 3/1. Is that right? Alright. Now, let's go and review that one more time. What we're going to do is, we're going to do 1/2 minus 3. I'm going to write it is 3/1. What is the common denominator? The common denominator is 2. And now, what do? Look at this where I'm pointing. This common denominator divided by this 2 divided by 2 is 1. And that 1 is multiplied with 1 on that numerator, followed by that minus. Is that right? That's what I have here. So once again, 2 divided by 2 is 1. 1 multiplied by that 1 is 1. That's what I have there. Okay. Followed by the minus. And now 2 divided by 1 is 2. And that 2 multiplied by 3 is 6. That will be 1 minus 6. Is that right? Okay. Let's move on. So 1/2 minus 3 simplifies to 1 minus 6 divided by 2. And 1 minus 6 is negative 5. Tell me, what is absolute value of negative 5/2? Absolute value of negative 5/2 is positive 5/2. So the right hand side and the left hand side are both the same. That means this ordered pair actually belongs to this relation. Okay? Let's move on. Determine whether 1, 1 is an ordered pair for the relation y equal to x squared minus x minus 1. Alright, what do? Well, our ordered pair 1, 1 means when x equal to 1, y also equal to 1. So, replace your x by 1 in both cases and replace your y also by 1 and see if the relation remains good. Alright, let's use x equal to 1 and y equal to 1. What does that become? Y equal to, y becomes 1, x squared becomes 1 squared, minus x becomes 1 minus 1. Is that right? X squared minus x minus 1 becomes 1 squared minus 1 minus 1. 1 squared is 1 and minus 1 minus 1. What is minus 1 minus 1? Adding two negative numbers is minus 2. And what is 1 minus 2? 1 minus 2 is negative 1. Is that relation true? Well, the left-hand side is 1. The right-hand side is negative 1. What's your conclusion? Well, this is not true. Therefore, 1, 1 is not an ordered pair of a relation. Alright, can you tell me, if the input value is 1, what will be the output value? Can you do that on your own? Put x equal to 1 and find the value of y. Alright, let's do that. Just watch below the equation. When x equal to 1, I would say y equal to x squared, I'm going to write 1 squared minus 1 minus 1. And what's that equal to? 1 squared is 1 and that will be minus 2. That's equal to negative 1. So an ordered pair of this relation will be when x equal to 1, y equal to negative 1, or 1 negative 1 is an ordered pair of that relation. Alright, I want you to do one thing on your own. Complete the table of ordered pairs for the equation 3x minus 5y equal to negative 15. So that's an equation or a relation. Remember, a relation establishes a relation between an input variable and an output variable. 3x minus 5y equal to negative 15 is a relation between x and y. And I want you to complete this table. Now, in the first case, I have given you the value of x. You need to find the value of y. Alright, so what do? In case 1, we solve for y when x equal to 0. So, put x equal to 0 here and find the value of y and right there. Let's do that. 3 times x equal to 0, minus 5y equal to negative 15. Now, how would you solve this? What is 3 times 0? 3 times 0 is 0. So the left-hand side now simply is negative 5y. Negative 5y equal to negative 15. What do you do to solve for y there? You know what to do. Divide both sides by negative 5. What does that give you? If you divide both sides by negative 5, you get y equal to positive 3. So, when x equal to 0, y equal to positive 3, or the ordered pair is 0, 3. When x equal to 0, y equal to 3. I hope you understood that. Alright, let's go to the next case. Here, the output is given to be 0. You need to find what input will cause that output to become 0. You know the value of y, find the value of x. So what do? Replace this y by 0 and solve for x. Let's do that. That would be 3 times x minus 5 times 0, that's the value of y given, equal to negative 15. Well, 5 times 0 is 0, is that right? That means you get 3x equal to negative 15. What do to find x alone? Divide both sides by 3. And then what do you get? Well, if you divide this side by 3, you get x. Divide the right side by 3, you get negative 5. So x equal to negative 5. when y equal to 0, x equal to -5. How do you write that ordered pair? Well, that ordered pair is this, -5, 0. Remember, ordered pair always comes with the value of x first. So when y equal to 0 happens, for x equal to -5. What about case 3? Let's go to the next slide. For case 3, you are again given the value of the output. You need to find the input. What input will cause an output of -6? So what do? In this relation, replace your y by -6 and solve for x. Let's do that. 3x minus 5y. In place of y, I put -6. Okay? In simplifying this, you got the double negative. Is that right? 3x minus -6. 3x minus 5 times -6. How does that simplify? It will become 3x plus 30. No problem there? 3x minus 5 times -6 is positive 30. 3x plus 30 equal to -15. What do you do to solve for x? Move that positive 30 to the right. It will become -30. Alright? We have 3x equal to -15 already there. This 30 from the left moves to the right, become -30. And what is this? -15 minus 30. What is -15 minus 30? That would be -45. 3x equal to -45. Can you solve that on your own? To solve for x, divide both sides by 3. There you are. So divide the left-hand side by 3, you get x. Divide the right-hand side by 3. -45 divided by 3 is -15. X equal to -15 is when x equal to -15 is what will produce an output of -6. So the ordered pair is -15, -6. Okay? You should be able to do problems like this. So as soon as you finish watching this, you must go back and do all the homework. I have similar questions for you in the homework. Let's now talk about graphing ordered pairs. How do we use the ordered pairs to construct a picture of our relationship? Alright, so let's see how we can graph ordered pair. An ordered pair is a point that can be marked on the xy coordinate system. You see, we have talked about the xy coordinate system having first quadrant, second quadrant, third quadrant, fourth quadrant, and so on. Now, when you have an ordered pair, you can judge where does that ordered pair belong to. Okay, let's see. This is now the Cartesian coordinate system. You can now mark our ordered pairs here. Let's see how we can do that. Let's see the ordered pair 2, 5. How will you mark the ordered pair 2, 5 on the Cartesian system? Which quadrant is it going to fall? You see, x is positive, y also is positive. It is a first quadrant number. Now this is how we go. X equal to 2, you go from 0 to 2. Then y equal to 5, move 5 places to the left. You see that? That is the point which is called x equal to 2 and y equal to 5. We call it 2, 5. And that's the way we will mark an ordered pair in the Cartesian system. Is that right? X equal to 2, go 2 places to the right. Y equal to 5, go 5 places up. You will come to the point x equal to 2, y equal to 5. That's easy, is that right? You can do that. Let's mark this point. -3 2. Where will you mark that one? What quadrant does it belong to? X is negative, so X negative. Y is positive. It obviously belongs to the second quadrant. So X negative 3, go 3 places to the left. And Y is positive 2, go 2 places up. And that is X equal to negative 3, Y equal to 2, or the ordered pair negative 3, 2 is marked like that. Now, you must notice that I cannot mark these points exactly at the center where I want, because the computer doesn't let me do that. So remember that this is supposed to sit at that intersection. Okay, how about negative 5, negative 4? Where will you mark that point? X is negative 5, Y is negative 4. So what do? You go X negative 5 and Y negative 4. There will be your point. There. Oops. Yeah, there you are. X equal to negative 5, Y equal to negative 4 is there. That is negative 5, negative 4. Let's mark one more point. 8, negative 6. X is positive, Y is negative. I'm sure you can mark that point, can't you? How do you mark it? X is positive 8 and Y is negative 6. So go 6 places to the right on the x-axis, then go, 8 places to the right on the x-axis, and go 6 places down on the y-axis. That is your point. 8, negative 6. So you should now be able to mark any point on the Cartesian coordinate system. Once you can mark ordered pairs, you can draw a graph of any relation. Okay. Let's now do some of these points. Determine the quadrant of each ordered pair. Well, you can tell me. Negative 3, 1. Which quadrant does it belong to? X is negative, Y is 1. Alright, X is negative, Y is positive. Which quadrant does that point belong to? Well, it is a second quadrant point. X is negative 3, Y is positive 1. So that's a first quadrant point. How about this? 36, 41. X is positive, Y also is positive. X is positive, Y is positive. It belongs to the first quadrant. But can I mark it on this? Well, I haven't got enough values marked on the axis. The point will come somewhere way out on the board. Is that right? Alright, how about this? Negative 24, negative 8. Which quadrant is that point? X is negative, Y is negative. So X negative, Y negative. That is a third quadrant point, right? Okay. Let's now mark these points on the Cartesian coordinate system. I have given you points A, B, C, and D. Alright, let's mark these on the Cartesian coordinate system. Point A is negative 4, negative 2. Where is that point? Can you locate that? X equal to negative 4, Y equal to negative 2. That is the point. A, negative 4, negative 2. Alright, let's go to the next one. B, 3, 2. Where is that point? X is positive, Y also is positive. X equal to 3, Y equal to 2. There is the point. B, 3, 2. I hope you understand and appreciate the fact that this dot that I put must ideally be at the intersection, but it doesn't obey me very often, so it gets slightly displaced. Okay. Point C, 2, negative 3. What quadrant does that belong to? X equal to 2, Y equal to negative 3. There you are. C, 2, negative 3. So you can mark any ordered pair like that. We got one more point. D, negative 3, positive 3. X equal to negative 3, y equal to positive 3. Where does that point come? X equal to negative 3, y equal to positive 3. D, negative 3, 3 is that point. Okay. Let's now use an example to illustrate this. Okay. The maximum benefit for the heart from exercising occurs if the heart rate is in the target zone. The heart rate is in the target zone. What is the target zone for the heart rate? How many of you know what is the best number of times your heart must beat in a minute? Well, if you ask your doctor, it's in the neighborhood of 72. All right. The lower limit of this target zone is approximated. In other words, how low can it go and still you can be healthy? And here it is given as a mathematical equation. It says y equal to negative 0.7x plus 154. And that is the relationship there, where x is the age, the independent variable is your age, and y is the number of heartbeats per minute. So it tells you actually that the number of heartbeats, y, depends on your age. As you become older, the number of heartbeats can change. Okay. Complete the table of values for this equation. You see how mathematical equations are used in ordinary life. Doctors use these. Well, no, not quite. Doctors don't use it, but people who do research will use it. So complete the table of values. Here are the table of values. I've given you 4 values of x. Tell me, what are the values of x here representing? X represents the age of a person, and y represents the lower limit of the heart rate. Okay? For a person who is 20 years old, what is the lower limit? What is the lowest number of times the heart can beat and you still can be healthy? Alright, so you got to do 3 things. Complete the ordered pairs, then write these as ordered pairs, and make a scatter plot of the ordered pairs. What is a scatter plot? When you mark these ordered pairs on a Cartesian system, it is called a scatter plot. The points are scattered on the Cartesian system. Okay? Alright, let's do that. What do? Put x equal to 20 in this relation, find the value of y. When x equal to 20, let's replace x by 20 there. I get y equal to negative 0.7x. In place of x, I have 20 plus 154. Well, how many of you can tell me without a lot of effort, what is negative 0.7 times 20? Well, if you have difficulty multiplying, 0.7 multiplied by 20. To do that, just multiply 20 by 7. 20 by 7 is 140, is that right? But there is 1 decimal in the multiplication, so you need to move the decimal 1 place to the left. I think I'm going to show it to you for some of you who don't know. Alright, look at the way I'm going to multiply. 20 multiplied by, this is 20, multiplied by 0.7. What you do is first multiply 20 by 7. 7 times 0 is 0, 7 times 2 is 14. And now, because there is 1 decimal place in here, we need to have 1 decimal place in the answer. So go from right to left and put your decimal there. That is the answer. So, if 20 multiplied by 0.7 is 14, then negative 0.7 multiplied by 20 will be negative 14. Is that right? So that will be negative 14 plus 154, that will be 140. When x equal to 20, y is 140. Alright, can you do the next one? When x equal to 40, y will be negative 0.7 times 40 plus 154. Now, I will not help you with this. You need to do this on your own. Negative 0.7 times 40. Well, I can do it quickly for you. That would be negative 28. And negative 28 added to 154 will be 126. So when x equal to 40, y equal to 126. Alright, let's do the next one. When x equal to 60, put x equal to 60 in the relation, y equal to negative 0.7 times 60 plus 154. Now look at the way I'm going to do this. 7 times 6 is 42. That means negative 0.7 times 60 is negative 42. And negative 42 added to 154 is 112. So when x equal to 60, y equal to 112. Okay? When x equal to 80, put x equal to 80, and what do you get? Y equal to negative 0.7 times 80. That must have been 80. You need to make a small correction there. That's not 60, that will be 80. So, that will be 80. Okay. Negative 0.7 multiplied by 80. What is that? What is negative 0.7 multiplied by 80? 7 times 8 are 56. So that will be negative 56. Added to 154 will be 98. Is that right? Yes, let me go back in there. Alright, so that will be 98. You should see that is to be corrected as 80. So when x equal to 80, y equal to 98. Okay, we have done the first task. Write the data as ordered pairs. Well, actually they are written as ordered pairs, but you need to write them in the form. How? Well, look at this. The ordered pairs are parenthesis 20, 140. X equal to 20, y equal to 140 is the first order pair. Alright, when x equal to 40, y equal to 126 is the second order pair. X equal to 60, y equal to 112 is the third order pair. X equal to 80, y equal to 98 is the fourth order pair. Alright, let's now do the third. Make a scatter plot. Draw a picture. Right? Alright. For that, let's carry our ordered pairs. And to do a graph, what I have done is, because I have only positive values of x and positive values of y, I have taken the first quadrant, and in place of just numbers 1, 2, 3 up to 10, look at the way I have put my x values. I know my x values have to go up to 80. So each division I called 5. You see 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and so on are the x values. And y values, what I have done is, I said y values range from 98 to 140. So, rather than saying 0, 5, 6, and so on, I put a wiggly line there saying there is a lot of part there which I'm really not going to use. So I've sort of folded it up. And I started here at 98. And this is 112. That means there are 4 divisions is 14. So this is 98 plus 14. This will be 112 plus 14, and this is 126 plus 14. So I've got those numbers there. Let's now mark the ordered pair. What's the first ordered pair? X equal to 20, y equal to 140. X equal to 20, there you are. Y equal to 140, there is the ordered pair. That is 20, 140. Alright? What's the next one? X equal to 40, y equal to 126. X equal to 40, y equal to 126. There is the ordered pair. Where's the third one? X equal to 100, x equal to 60, y equal to 112. There is the ordered pair. And the fourth one, x equal to 80, y equal to 98. That is the ordered pair. Tell me, what does this picture tell you about the heart rate as related to the age? You can see as you age, the minimum number of heartbeats for you to remain healthy keep decreasing. See? But these numbers are actually not very good. I just wrote down a relationship. It is not a correct relationship. So the doctors will find fault with me. But what the picture tell you, what the graph, you see every graph will have a story to tell. And what is the story this graph has to tell? It tells you as you grow older, the number of heartbeats will actually decrease. Okay. Well, my average heartbeat is about 65 per minute. Sometimes it will vary, but that's about the number. But younger people will have 73, 75, up to 80, 90. They are normal. You grow older, your heart rate could come down. Well, I think we have done the introduction to graphing, and we're going to use this in our next 3 lessons to build up how we construct a picture of a relationship by graphing. Alright? Well, you've got to now go back and do your homework. Alright? I'll see you for the next lesson later on.